Okay, so to solve linear inequalities, it's really basically the exact same process, right? We still want to simplify each side. We're going to try to isolate all of the variables on one side, all of the constants on the other side. Usually you want the variable with an inequality to be on the left. And the reason why that is like if you say that x is greater than 5 and you graph that, here's 5, the arrow, if your variable is on the left, your arrow, the inequality, will point in the same direction you shade. So it's just like a little bit less confusing if you make sure that your variable is on the left. It doesn't have to be that way, but realize if this was written the other way, 5 is less than x, it's like a mirror image, and you would actually have to, switch the sign with the number and the variable. If you want the variable on the left, then you would have to flip the sign as well. Okay, now we're going to isolate the variable by doing multiplication and division. That should be our last step. And then our check, what kind of checks were we doing for the inequalities? How many checks? 2 checks. What were they called? Yeah, you want to check it to make sure you did your math right. That's an equation check. 2, you want to check your actual solution set. So we said we would use an inequality check. Okay. And then to summarize, you're going to state your solution in set notation, solution set. And actually for inequalities, we're using, we use a complete sentence if it's a word problem, but for these, we're also using the graph. We're graphing the inequality, we're writing the interval notation, and the set builder notation. So let me show you how this one would work, okay? And remember, what's the one special rule about solving inequalities? Special rule is if we multiply or divide by a negative, we are going to flip the inequality symbol. Okay, so here, first thing I'm going to do is subtract 5, so I can get the 3x by itself, negative 3x. I don't flip this yet, is 6. And now, because I'm dividing by negative, not because I'm dividing, sometimes people get that confused and they'll just always flip the signs. That's only when you divide by a negative, negative 3, that right away we want to flip that inequality to the opposite direction, negative 2. Then I was saying for your first check, you want to treat this like it's an equation. Negative 3 times negative 2 plus 5 equals 11. Does it? 6 plus 5 equals 11. 11 equals 11. The reason why we do that equation check is because we want to make sure that we got the right borderline number. I want to make sure I didn't make any mathematical errors along the way, and I want to make sure that this number, negative 2, is really the borderline, because it's not the solution. Negative 2 is not the solution because it's not an equation. And then if I go over here, it's going to be easier for me to do my interval notation if I start with, let's say, okay, here's 0, here's negative 2, here's positive 2, and we're less than negative 2. So remember, we're putting the parenthesis on negative 2. We're shading below negative 2. And you see how, since x is on the left, the inequality points in the same direction that you're shading. And then your interval is going to be from negative infinity to negative 2, and we put parentheses around that. We always think about where do I start and where do I stop, and then the set builder x such that x is less than negative 2. Now you're also saying, well, I want to know if that shaded area is correct. There's 2 different ways you could check the inequality. For the second check, you could plug in a number in your shaded area, and that will make this true. Or if you pick 0, because 0 is an easy number, you will find that since it's not in your shaded area, it will make the statement false. And that's okay because you're checking a number that's not included in the set. So if I plug in 0, I just like to use 0 because 0 is an easy number. I'm not going to pick -2 because that's not going to tell me do I have the number, the shaded area correct, right? That's what with the inequality check, I'm trying to see, did I shade the right half of the number line, right? So if I pick something like x equals -5, and I plug it in, I get -3 times -5 plus 5. Is it greater than 11? I don't know. 15 plus 5 is greater than 11. Yes, 20 is greater than 11. So that comes out true. Now, if I used something like x equals 0, you're going to notice I'm going to plug it always into the original. -3 times 0 plus 5 is greater than 11. Well, this gives me 5 is greater than 11, which is false. This one was true. And then I have to train myself to think, oh, well, I want that to be false because 0 is not a solution. It's not in my shaded area. So that's just sort of a little bit of a trick about using 0 because 0 is such an easy number to work with. And especially when we get to graphing later, we're going to find out just how easy 0 is to work with, okay? Any questions on this? Yes, Jocelyn? The extra check, the second check? Yeah, I do. Well, I mean, oh no, I don't think you have to check both sides. You really only have to do one of the inequality check, but I was just showing you what it would look like to pick a true, you have the option to pick a number that will make it true, and that should be in your shaded area, or you have the option to pick, if 0 is not in your shaded area, you could still use it. It's just, it could be confusing because it will come out false, but it should come out false because your solution set is not that area. Okay, and the only reason why we flipped the inequality is because we divided by a negative. Now, I can look through at the packet and find another one that's more challenging. Is there another one that you would like me to do as a demonstration? What about number 6? How about? Number 6 looks challenging, right? Okay, let's try this one together. So the first thing I'm going to do is I want to simplify both sides. I want to end up with one variable on one side and one number on the other. So what's the first property that I'm going to have to use here in order to simplify it? Yeah, distribute the -4. So this becomes -4 times 8 is -32. -4 times -y gives us +4y. I don't flip the inequality because I haven't done anything yet that requires me to do that, right? Now over here, I'm going to distribute the 7 only to these two and leave that one out because that's not in parentheses. So I get 7y minus 14 minus y. Everything over here is simplified because these are not like terms. Over here, I need to simplify further. I have 7y minus y. How many y's do I have left? Plus 4y is greater than 6y minus 14. And now I want to get all my y's on one side. Usually I like to try and get my variables. With inequalities, I said I prefer, it's not right or wrong thing, but I do prefer them on the left. I find that less confusing. So even though, obviously, if I subtract the 4y, I'm going to end up with a positive, I'm still going to force myself to make it negative. I usually don't do that with equations. So minus 6y, negative 32 minus 2y is greater than or equal to negative 14. And that's another area where I see a lot of common mistakes are people forgetting to, because that's left, bringing the negative with the 14. Okay? Now I want to add 32 to both sides to get rid of it here. And don't forget that negative 2y. Okay? And then, I don't know, what is 32? Is like 18? Is that right? 18. The reason why I got that was because I knew half of 32 was 16, but this was 14, so I had to add 2 more. Okay, and then when I divide by a negative, I flip the sign. Y is less than or equal to Negative 9. Oh, we're so happy when it doesn't become a fraction. Even me, okay? So I go back up here. Here's maybe negative 9. I don't know. I'm just going to put negative 9. Okay, maybe negative 7. Just so we know which direction we're going. Negative 11 is here. And we're going to actually, for this one, because it's less than or equal to, y is less than or equal to, it's all these numbers here, and we're using, instead of parenthesis, we're using a bracket. And that's because negative 9 is included. That could also be a closed circle. So you might have a closed circle at 9, shade below 9, or negative 9, I should say. Okay, that would be the same thing. The interval, it starts at negative infinity. It goes to negative 9. And what am I going to put around the negative 9? Bracket. And then set y such that y is less than or equal to 9. So we're just putting those curly braces around that. That's supposed to be a y, not an x. That was my typo. Okay. So again, if I can always go back to my equation and check negative 9 as an equation check. So my first check looks like negative 4 times 8 minus negative 9. That's a lot of things. We want to know, is that equal to 7 times negative 9 minus 2 minus negative 9? So anytime you're substituting, especially a negative in, it's a really good idea to use those parentheses so you can see that minus and negative. You don't want to skip that part, otherwise your check won't work out. And you could even do this on your calculator here, but this is going to be negative 4 times 17. Does everybody see where I got 17? That's because this becomes minus a negative, becomes plus a positive. And I don't know what negative 4 times 17 is, so I'm going to use my calculator for that. Negative 68. And let's hope this other side comes out to negative 68. So we have 7 times negative 11. And this is also minus a negative becomes plus 9. Negative 77 plus 9. I hope that is negative 68. I think it is, right? But this is where using 0 and getting a false might be helpful, right? Because there's a lot going on, a lot of negatives. So you can kind of see the advantage of using 0, but you just have to train yourself that, okay, if I use x equals 0, which is over here, 9 units over, okay? If I use that, I'm expecting this to come out false. So let's see how that would look. I'm just going to find some space. Okay, maybe I'll do it up here. Second, check, negative 4. Once I plug in y equals 0, doesn't y just disappear if it's 0? So I have 8. Well, 8 minus 0 is still 8, right? So this is going to be negative 32 is greater than or equal to. Over here, 0 minus 2 minus 0, all I have is 7 times negative 2. Does everybody see where I got that? If I just replace 0 in here and 0 in here, 0 minus 2 is negative 2. So that's why I like using 0, because I can do a lot of mental math. Negative 32 is not greater than negative 14, but 0 is not in my shaded area, so 0 won't work. So my check will come out false, and that's a good thing, because if I had forgotten to flip the inequality, I would have shaded the area that contained 0. You see what I'm saying? So the second check tells me, did I shade the right direction? Okay, so let's have you try a few of those, and then we'll get to some word problems.